Excursions form a part of a school's educational curriculum in a bid to inform, expose, and educate the students to career opportunities and to gain knowledge. Recently, the management of Rhemite School, located on number 7 Lanreto Wabola Close off Awori Street in Lekpo Alaji Bus Stop, Unity Estate together, organized an educational career tour for the students to the Nigerian Naval Dockyard Limited, located on Ahmadu Bello Way, Victoria Island, Lagos.
You are welcome to Naval Dockyard Limited. I want to believe before now you've been hearing of Naval Dockyard Limited, but presently now you will know what we do here. Naval Dockyard Limited is an engineering naval institution that carried out ships building, maintenance to Nigerian Navy ships and commercial vessels as well. Here in Naval Dockyard Limited, we have different departments that carry out different assignments towards achieving our goal of either building ships or maintaining ships. One of the departments are as follows. One, we have ships design office. Two, we have heavy engineering workshops. We also have electrical workshops. And we have pondering workshop.
Electricals. We have the foundry workshop. Foundry, FOUNDRY. We have the ship design center.
The students were taken on a tour to the various departments where ships are being designed, fabricated, and repaired.
So this is the ship design center of the Nigerian Navy, where we design ships and everything you see at the water. We do the design here. The person that designs ship is called a what?
Ship designer.
You're right. Good. Not for yourself. But the actual name is in Naval Architects. In Naval what?
Look this way.
So who is in Naval Architects? Very good. So I am a naval architect with the Nigerian Navy. So we design ships for the Nigerian Navy. The ships you see out there at sea, we call it our coastal patrol vessel, which we use to protect our Nigerian waterways. So what I say, a ship designer in naval architecture school, a person that does what? That designs ships. That's very good. And naval architecture is a branch of what? Engineering. How many of you want to be an engineer? Very good. So you can see on the TV, this is a picture of one of the ships that we designed recently. It was built here in Naval Dockyard Limited. Have you been on board the ship?
No.
Would you like to be on board the ship?
Yes.
Fantastic. We'll take you on board the ship outside here, okay? So you see what the ship looks like. So can you see the picture?
Yes.
So that's one of the ships we built recently. This way to go.
Yes.
You want to learn how to design a ship?
Yes.
Oh, fantastic.
Listen to him. No noise.
So how do we design a ship? One of the colleagues asked that question. So you can see on this computer. How many of you have a computer? Very good, very good. So there are different marine softwares which we use in the design and analysis of our ship. So once we're done designing in our computer, we'll take it out on the construction site and build it. There are various ways in which we can build and design a ship. We'll play a video shortly to show you the process of the construction. So once the design is done here, we take it out, as you can see over there. This is the construction phase of our ship that was designed. So what's going on right now is cutting of the plates. So once you're done designing your ship in the ship design center, we take it to the construction facility where we start production of our ship. Anyone have any questions so far? Where do we get what? The plate from? Very good question. Someone asks, where do we get our plates from? Have any of you heard of Argentina steel? No. No? Okay, so back in the days, we produced our steel in Nigeria. But most of our steel is being imported from other countries that make steel. Then we go to our local market to buy most of all these steel plates used in our construction.
It was indeed an interactive session as students were asked questions and they answered intelligently. Students were also given the opportunity to ask questions.
Yes, ma'am?
When ship built on water, even with made of iron?
Very good question. How can ship be built on water made of what? Iron. Have you heard of Archimedes' principle?
Yes.
Hmm?
Yes.
Who have heard of it? Raise up your hand if you know Archimedes' principle. What is it? What is it? Any idea? What do you think Archimedes' principle is?
How the ship floats on water?
Very good. You deserve it, stuff. You deserve it, stuff. So, basically.
Excuse me, do you know that guy is in GS2?
GS2.
Yes. See, the beginning and the fundamentals of shipbuilding starts from what? Archimedes' principles. The question you ask and the answer you give is the fundamental to shipbuilding. How does an object float when placed on water? That is the fundamental. It's called buoyancy. How does an object float? The water brings what? Force acting upward. The weight of your object brings what? Force acting downwards. So you need to know your material. When you progress later in your course, you start learning material selection. Why are some ships made of wood? Why are some ships made of steel? Why are some ships made of aluminium? Do you understand? So you start seeing different materials used in shipbuilding, but everything starts from what? Archimedes' principle. So to answer your question, read more on Archimedes' principle. When you place an object on water, it displaces some amount of water. And that's what makes your vessel float. Yes.
My definition of Archimedes is that when the body is complementary put in water, it experiences an upthrust.
Upthrust. What's an upthrust? Upward force. So it's that up force that makes your vessel not to sink. But guess what? If that object now, remember we said upthrust, right? Now, if that object is heavier than the upthrust force, what happens? Sinks. That's why in Titanic, when the vessel started leaking and water started entering the vessel, it got what? Heavier and made the vessel to what? Sink. Oh, so do we understand the fundamental now?
Yes.
Any other question? I like your question, please, more of it. Who takes care of the expenses used in the material and building the ship? Good question. So it depends on who is your client. If, for instance, you want me to build a ship for you, you will tell me, oh, I want you to build me a 100-meter ship that is very big or very small. Then I, as a project engineer, will do the costing to know what it will cost you to build the kind of ship that you need. So that's how I produce the bill of quantity for you. Do you understand? A bit too much? Do Navy officers use what bulletproof ship? Good question. Good question. So, like we said earlier, there are different materials used in what? Shipbuilding. And for naval ships, right? What are the things you face out at sea? Pirate attacks. So you need your ship to be what? Very strong. So we use what we call ballistic protection. To protect your vessel, ballistics. It protects your vessel from what? Gunshots. So it's like a bulletproof. So the ballistic protection is what? Like a bulletproof you wear around your ship.
So how does a submarine work?
How does a submarine work? What class are you now?
Jesus. Wow.
Oh, Jesus. Okay. So, there's a lot of physics and buoyancy that will go into this again. Remember what we told you about? Everything starts from what? Up thrust force. Everything starts from pressure. Everything starts about your weight being exposed. You see the same principle. If I want my object to sink, what happens? I will make sure the weight of my object is more than the upthrust from the sea. So if I want to go deeper down in the water, I have to make my vessel heavier to go deeper down in the water. If I want my submarine to come back up, I have to find a way to pump out that excess water inside the submarine to float back up. So that's how we manipulate it. Yes. How does the submarine engine work? Oh wow, fantastic question. How does the submarine engine work? So let's go back to the what? Fundamentals, right? What's the use of an engine? Why do we need engines on board a ship? Can anybody answer that? To what?
To make the ship move.
Make the ship move.
Who is that? Who has?
So what you say to make what?
Start again.
To make the ship move. Fantastic. To make the ship move. So the basic use of an engine is what? To make your ship to move. Do you understand? So with the engine produces power that helps us counteract what? The resistance of what? Of a vessel. Do anybody know the formula of power?
Yes.
What is it? Okay, fair enough. You all got it right. There are plenty, and there are plenty. As what? Acceleration what? Yes. So there's plenty formula for power depending on what you want to use it for. But in terms of ship design, let's look at it. Power equals what? Speed times resistance. So now you ask the question, how do an engine make our ship move? Now for a vessel to move, once it's going forward, there's going to be a resistance trying to push it back. So for a vessel to go forward at a certain speed, it needs to overcome a certain resistance. So the more, like when you're driving your car, when you press the accelerator, the engine goes faster. So same thing for an engine, by the time you increase the power of your engine, what happens? It overcomes the resistance and goes faster. So power equals what? Speed times resistance. So that's the fundamental principle of what how an engine works. Yeah.
Does the submarine has limits of depth when under the water?
Yes. So every vessel, every submarine are all designed to some specific standards. So for instance, like I told you earlier, if you come to me and tell me as my client that, oh, I want my submarine to be able to do this or go this this depth in certain water, I will design according to your specification.
Does the ship need a limit where it can move to?
Yes. Yes. Very good. Yes. Fantastic. So the ship have what a limit to where it can go to. They call that what? Endurance. Endurance. So for instance now, if I want my ship to go all the way to say Cotonou, I need to know the amount of what fuel it can carry. Because your engine needs to be burning this fuel to move. So your carrying capacity, usually your fuel, your water, determines how far your vessel can go to. Do you understand?
Yes, sir.
Sorry? Have you ever seen anything amazing under the water? Have you watched this movie, Little Mermaid?
Yes.
Under the sea?
Yes.
That's what I have to say for that. Any
We have students who are already, rounding on SS3 and like looking at the career path. So let's know the career path, to be in the maritime or in a sector like this.
Oh, fantastic. I'm going to be
So clap for me.
SS3 students, let me see. SS2.
Okay, still need to ask.
SS2 students.
SS2, SS1, SS2. Because from SS1 you're planning your career.
Okay, true.
SS1 you're planning your career from SS1. Can we see your hands up?
Fantastic. So in the field of sciences, in the field of engineering, if you can see in the engineering sector, it's divided into various departments. You have the likes of the petroleum engineers, the mechanical engineers, the structural engineers, the various different departments in engineering. But it's a fundamental. When you graduate, basically your first 2 years in any university, all engineering courses are basically the same.
Listen.
Do you understand? Every engineering courses are what basically the same. Let me let you know that what you learn in SS1, in SS2, in your secondary school, will actually take you more when you actually graduate university. What you learn in secondary school is actually more than 70% you need as an engineer. So what I would advise you in SS1 and SS2 and SS3, pay close attention to your fundamental. Everything else is all extra. Like that question you asked, why do ships float? It all starts from the basic. And this is what you learn in your SS1 or your SS2, the fundamentals. Once you know your fundamentals, like when you're building a house, the most important part is your foundation. Make sure your foundation is upright. Make sure you learn the basics of your sciences.
The Nigerian Naval Dockyard is a shipbuilding and repair dockyard for military and commercial vessels. They have over the years built some vessels for the Navy and also rendered services to commercial vendors.
Heavy engineering workshop. What did I say this workshop is?
Heavy engineering workshop.
Very good. Why it is called heavy engineering workshop is because there are heavy equipment in this workshop, and mostly in this workshop we deals with heavy metals in this workshop. And as you can see from my right here is a lathe machine. Lathe machine. And in this lathe machine, as you can you see it from that place? You should come here a little bit. Now this is a lathe machine. We call it lathe machine. And in lathe machine can be used to carry out different activities. You can use lathe machine to carry out turning operation. What did I say? You can use lathe machine to carry out how many operations? Plenty operation. And one of the operation is what? Turning operation. Turning. One of the operation is turning operation. Are you people writing?
Yes, sir.
The second operation you can use slate machine to carry out is boring operation. Boring. Boring operation. Boring. Turning. Turning operation. Number 2 is boring. And the number 3 operation you can use this machine to carry that is reaming operation. Reaming. R-E-A-M-I-N-G. Reaming operation. And you can, as you can see, the machine consists of 3 most important parts. We have the headstock. This is the headstock. The headstock. Headstock. On the whole head, then you put stock. Headstock. I say, what did I say this thing is?
Headstock.
Very good. And this one we call it the chalk. This is where you tight. If you want to put your equipment here to work on, we call this place chalk. This is where you tight the equipment. What did I say it is?
Chalk.
Chalk. So write it. Then we call this place spindle. Spindle.
Spindle.
Yes.
I want to know spindle.
S-P-I-N-D-L-E. Spindle. Yes, spindle. Yes. Like this. Then this part of this machine, we call it the carriage. The carriage. Then this part of the machine is the supporting part of the machine. We call it the tail stock. The tail stock. On the whole tail, then you put stock. Tail. T-A-I-L. Then you put stock. Tail stock. So how many parts did I say this? How many major parts did I say this machine consists of?
3.
3. Can you name it for me?
Headstock.
Okay. The chalk consists of the chalk, the spindle. Then it consists of 3 major parts: the headstock, the tailstock, and the carriage. Then in the headstock we have the chalk, the spindle. So you put the headstock under the headstock. That is where you put the chalk and the spindle, because they are part of it. Are you hearing me? That is the name of the make 2000 series MTU engine. 2000 what? 2000 series MTU engines. What did I say it is? No, you did not get me. 2000 what? MTU. MTU 2000 series. That is the name of this engine. What did I say the engine is? 2000 MTU series. So in MTU engines, they are all divided. There is 2000 series, there is 4000 series. So, but this one is what? 2000 series. So we are not going to go deep into it. We'll just show you this is what it is. So we'll go to the next equipment. You say what?
What's the function?
The function. This is an engine. It's an engine in a ship. What they use the MTU 2003 is what we use to propel the ship. Are you hearing me? We use the engine to propel the ship. Without the engine, you cannot be able to move the ship. Every engine has an engine. every ship, sorry, has an engine, and engines are divided into two. There are some that this one we call the inboard engines because they are inside the ship, and those engines that are outside the ship we call them what? Outboard engines. So we call this one inboard engine. Do we understand? Because they are what? They are found inside where? Inside the ship.
Students were also taken on board a ship to learn about the workings of a ship.
Now, you know this is Nigerian Navy. What does Navy do? They work on water. And we also work underwater. The use of what? Submarine. Abi? Yes, sir. Now, in this yard, you must have been told, what do we do here? We repair ships and we build ships. So you have the golden opportunity of entering the ship, going on board. Where do we steer the ship? From the what? Bridge. Do you tell something about the bridge? Yes. Bridge is a place, you know the person that controls the ship is called the captain. Do we know that? Yes, sir. Now, when ship is going around, the captain will be at the what? The bridge. Now, let's look at this ship. Have you all seen this green ship? Do you see the glasses at the topmost end? That is where the bridge of the ship is. So, gentlemen, you have a golden opportunity to go to that place now. Are we happy? Yes! We are on top water now. Wait, we are on top water. So you go up now. One after the other. We have an engine. And we have engine room downstairs. Me now, where you are now is what you call the bridge. You want to start, if I don't know whether I can take one or two of you to the engine room. Come and see how.
You remember what I told you people last in the other workshop? I told you people that there is that empty engine you people saw is the what? Is the one that used to drive the ship. So the engine supplies power to this place so that you can be able to what? Drive your ship.
Sir, what did I call that? Yes.
Gyro compass.
Huh?
Gyro compass.
Sir, what is it used for?
It's used for steering the vessel.
Navigation. When the ship is going. Now we have the north, south, east, pole. So when you are moving, this is the gyro that will tell you are southwest, northeast, degrees in degrees. You understand?
And we have two types, gyro and magnetic compass. Gyro compass and magnetic compass.
Okay. How do we start the engine? Do we start the engine?
That's the way you start your car.
Thank you. There's a button to press that will send signal to the engine. The engine they show you in the workshop. Can you remember?
Yes, sir.
Once there's a button in the engine room, once you press it, the electrical system will ignite it and there will be fuel in the engine, then the engine will start. Then for the steering of the engine, when the engine starts, that means the ship is ready to move. Then the captain will start doing what? Moving as if you are driving your
car.
Okay.
How do you drive?
How do you drive it?
How do you use to drive?
See, in a car, we have what we call the steering wheel, right? For ship, this is what we use. If you want to go left, right, it's on. This is where you do the direction of it. As if you are one is emergency. No, why it's called emergency?
Yes,
When very good. When one fails, you choose the other. When these two fails, you use this one. See, you can see that at times. Let's do it one
Question
by
one after the other. If you have questions,
when your dad drive car, you tell you I want to go to mechanic. Same thing, because the car uses what? An engine. Same thing, this one uses what? Engine. So engine might have fault. So instead of, for instance, you are at sea, and the engine have, instead of it to remain there, you use this emergency steering wheel to bring it back to jet. The tree cannot spoil at the same time. The tree cannot fail at the same time.
It was indeed an interesting tour as students, tour guides, teachers, and the school authorities took pictures at the dockyard.